Good morning, students. Good morning to all of you. Today we are going to discuss questions related to the topic gravitation. Let us say here the questions: a stone and earth attract each other with a equal and opposite force. Why then we see only the stone falling toward the earth, but not the earth rising toward the stone? Let us see here. Suppose this one the earth. Okay. Suppose this one the earth. Okay, and this one the stone. Okay. We see that the stone is falling toward the earth, but the earth is not rising toward the stone. Why this is happening like that? We have to answer these questions. Let us see here. Suppose this one the stone, okay, having a mass that is equal to, we assume that 100 kg, okay, and we know that the mass of the earth that is equal to the capital M. We indicate from capital M, that is equal to, we know, 6 into 10 to the power 24 kg. Okay. We know that the earth is applying some forces on the stone, that is gravitational force. We know that according to law of Newton's gravitational law, that every massive object attracts each other with some forces. The forces are attractive in nature. Okay, these forces are equal in magnitude, but the direction is opposite. Let us see here. Suppose the earth is applying some forces on the stone, that is equal to F1 attractive force, and the stone also attracts this earth from gravitational force, that is we indicated F2, and we know that the F1 equal to F2. We already know about it because according to the Newton's gravitational law this is happening, and these forces are opposite in direction. Okay, these forces are opposite in direction. We know that this one the opposite in direction, but the magnitude is same. But still the stone is why falling toward the earth, but the earth is not rising toward the stone. Why it is happening? The forces are equal, but why the stone is falling toward the earth? The question is like that. Okay, then we are going to discuss this answer this question. Let us see here. Suppose if you find out the force F1 here, then what will be the magnitude of the force? That we know that G M1 means the mass of the stone, M2 means the mass of the earth divided by R square. R means the distance between the two objects. The distance is to be taken from center to center distance. Suppose this one is the center of the earth, this one R, we assume it. Okay, so the F1 becomes how much? G M upon R square. And again the F2, this will also becomes how much? G small n capital M divided by R square, because these forces are equal. And if you want to find out the acceleration of the stone, then what will you do? If you want to find out the acceleration of the stone, so we have to divide the force which is acting on the stone, that is F1, the force which is acting on the stone, that is F1, by its mass. Then we can find out the acceleration of the stone according to Newton's second law of motion, F equal to mass into acceleration. Okay, so from here F1, the value of F1 equal to Z small m capital M divided by R square, and the small m here, the cancel out, and the stone acceleration becomes how much? G capital M divided by R square. This one the acceleration of the stone. And we know that the acceleration of the stone is fixed, that is acceleration due to gravity, that is how much? Acceleration of the stone is fixed, that is a small g. We have already discussed about it, that is acceleration of the stone is 9.8 meter per second square, and approximately it becomes how much? 10 meter per second square. It is fixed. Okay, and after it, if you want to find out the value of acceleration of earth, then what will you do? We have to divide the force which is acting on the earth, that is F2, and by its mass, the mass of earth. Okay, then what will you gain? From here we see that this one becomes how much? F2, that is equal to G small m capital M divided by R square, and this one the capital M. Okay, the capital M will be cancelled out and gives a value G small m upon R square. This one the acceleration of earth. Okay, this one the acceleration of earth. If you want to find out the comparison between the acceleration of the stone and acceleration of earth, we have to find the ratio of the acceleration of the stone to the ratio of the acceleration of earth. It means we have to divide the acceleration of earth, acceleration of stone to the acceleration of earth. Then what will you get? We get G capital M divided by R square, and this one G is small m divided by r square. The r square we cancel out, the g also we cancel out. We see here the acceleration of stone divided by acceleration of earth becomes how much? Capital M divided by small m. And we know that the acceleration of stone, how much acceleration of stone we have know about it, 10 meter per second square. So if you put the acceleration of stone here 10 and the acceleration of earth we have to find out, then what will you get? The mass of earth we know that 6 into 10 to the power 24, and the mass of stone we assume that 100 kg. So we put here 10 to the power 2 kg or 100 is 10 to the power 2, it will be cancelled out and give a value 22. Then again it will be cancelled out, it will give say 21 from here. Then if you want to find out the value of acceleration of earth, then what will you get? 1 upon, it will be reciprocal, gives and 1 upon 6 into 10 to the power 21. Okay, this will gives a value acceleration of earth. You see here the 1 is to be divided into 6 into 10 to the power 21 parts. If you divide the 1 into 6 into 10 to the power 21 parts, the value becomes very less, very less, it will becomes very less. So we can write here that the acceleration of earth is becomes very less than in compared to the acceleration of stone, and due to which the acceleration of earth we cannot conclude, we cannot observe the acceleration of the earth, but we can observe, we can see that the stone is falling toward the earth, but earth is not rising toward the stone. So we can write here the acceleration of earth could be neglected. Okay, can be neglected because of it's very small. So we see that, so we can say that the stone moves toward the earth, but not the earth rise towards the stone. Okay, I think you are able to follow me. Thank you very much.